All right, geometry, this is Unit 11, Homework 8. And this should be pretty straightforward because this is exactly what we did with Homework 7, only now it's 1/3 area of the base times the height. So now instead of having a prism that goes straight up, we have these pyramids and cones that go from the base to one point at the top. But everything else pretty much stays the same. So when we're trying to find the volume of this, it's 1/3 area of the base times the height. All right, so the base is, in this case, length times width, which is 10 times 11. And the height in this case is 16. The height does go from the middle here. These are right pyramids, so meaning that they go straight up from the middle here. So they're not leaning, they're not oblique. That's important. You need to use this height right here. Don't use the slant height. Don't use the height along the side here. Use the height that goes straight up from the center of the base. All right, and that gives you an answer for this one of 586.67, and that's cubic inches. Okay, let's try another one, only this time let's do one which you have to find that height, number 3. So to find the volume, we want volume equals 1/3 area of the base times the height. The base is a square, so we know that's base times height, 14 squared basically for the area of the base. That's easy. The height though, the height we want actually goes straight down to the middle here. So we need to make this right triangle and actually find this height. All right, we have the Pythagorean theorem though. We know this side's 7 because it's half of this 14. So we can do 7 squared plus our height that we're looking for squared equals 25 squared. And that would actually give us the height of 24. All right, so we'll use that there. And our final answer for volume then is 1,568 cubic feet. Okay, let's try number 5. We have volume equals 1/3 area of the base times the height. The area of the base is a triangle, and we don't have the base and the height. We have the base 14 of that base, the base of this triangle, but we don't have the height, which would be right over here. So I'll label this H. We're going to need to use the Pythagorean theorem again to find that. So it's going to be 14 squared plus H squared equals the hypotenuse squared. And we're going to find that height, and we're going to use that. That height comes out to 17.1. All right, so area of the base is 1/2 base times height. All right, so 1/2 14 times 17.1, and then times the height of the actual pyramid, which is 19. All right. And that comes out to 758.1 cubic meters. All right. Let's try a cone. A cone, once again, is still 1/3 area of the base times the height. But the area of the base is now a circle, pi r squared. All right. So in this case, the radius is 9. So we have pi times 9 squared times, and this is the height, which they gave us in this case is 17. Once again, the height will go straight from the like top point or vertex point up here to the middle of the base. All right, that gives us our answer. Once again, in these cases, we can represent our answer 2 different ways. We can give it as an exact value, or we can give it as a rounded answer. So as an exact value, that is 459 pi. Or as an approximate decimal, it's 1,441.99 cubic yards. Okay, the next problem, once again, volume is 1/3 area of the base times the height. The area of the base here is a circle, so pi r squared. All right. Now, the radius is easy to find. It's half of 27, 13.5. So that was pretty straightforward. But the height, we do need to find the height, and to find the height, we're going to draw that in and use this right triangle. So this is 13.5, and this is 22.5, so we'll do the Pythagorean theorem. All right, 13.5 squared plus the height squared equals the hypotenuse 22.5 squared. You guys can all solve that, and you exactly 18. All right, so the height is 18. We can use that and get our final answer for volume, which is, I'll just do the approximate answer, 3,435.33 and that's cubic kilometers. Okay, the application problems are some of the better ones in my view, the more challenging ones, and the ones I would definitely recommend you do. So let's do 10, 11, and 12. 10, a cone has a volume of 1,309 cubic centimeters. The height of the cone is 8. So this distance right here is 8. All right, let's find its radius. All right, so the volume is 1/3 area of the base times the height. They told us the volume was 1309. And the area of the base is a circle, pi r squared. We're looking for that r. And then they told us the height was 8. So we're solving this equation. So we're going to divide both sides by 8. All right. And we are going to multiply each side by 3. All right. And then we're going to divide both sides by pi. And we're going to get r squared equals, let me just do that real quick. I like to use the TI-84, which I'd recommend. 3 times 1309. You guys are going to use next year as this calculator. Divided by 8 pi. This ensures the 8 pi is in the denominator. Right? I mean, the other way you're going to enter it in is you're going to have to put parentheses around this 8 pi when you do the division in your guys' other TI-30 calculator. You got to make sure this pi is in the bottom, that you're dividing by pi. Alright. So that gives me about 156. Alright, 0.25. And the nice thing is this value is already in my calculator, so just take the square root of that, and you'll get your answer for the radius that we need, which is about 12.5. And since the volume was in cubic centimeters, we want centimeters for our radius. Okay, number 11 is a good application problem. We're going to build a sandcastle in the form of a square pyramid here. Alright, as shown. She bought 3 bags of sand, each containing, and it gives us the volume of each bag of sand. All right, and the question is, will she have enough to build a sandcastle? So we just need to find the volume of this and divide by this number 3 times, basically, or 3,600, whether or not she has enough. All right, this is a good problem. You know, you'd be surprised that you will use this stuff again. You know, if you go to buy wood chips for landscaping, for example, it comes in cubic yards. So they sell it by the cubic yards, which is basically one loader bucket full of a front loader. It carries a cubic yard typically, so you know you have to kind of figure out what is your area by 3 inches deep, and you can kind of ballpark how many cubic yards you're going to need. And so this is a good application problem. So let's find the volume of this pyramid first. The volume of the pyramid is 1/3 area of the base times the height. Area of the base is a square, so 25 squared, and the height is 18. So that's pretty straightforward. That comes out to 3,750 cubic inches. Now, if she's got 3 bags of this, then she's got 3,600. So multiply the 1,200 by 3 cubic inches. So she has 3,600 cubic inches. She needs 3,750. So she's short by 150 cubic inches. So will she have enough sand to build a castle? Not quite. Okay, and the last question, number 12, we have a cylinder that contains 2 congruent hollow cones. So these cones that are tip to tip here are hollow, so they're not going to be included. And we want to find the volume of this solid minus those 2. So we want the volume of the cylinder, and we want to subtract the volume of 2 cones. All right, so this is 20 inches tall, and it says this is 14-inch diameter. All right, so the volume of the cylinder is 1/3. I'm sorry, that's area of the base times the height, as we did in the last homework section. All right, and the area of the base is pi r squared. All right, and I guess I'll just finish that first. So the radius is 7. So pi times 7 squared times the height of 20. All right, now the volume of the 2 cones, we have 2, and the cone is 1/3 area of the base times the height. All right, the area of the base is a circle, so pi r squared. And we're dealing with this cone here, so we know that the radius is going to be 7. And the height of the cone is just 10, half of the 20. All right, so all we have to do is this calculation. I think you guys can all enter this into your calculator, and that will give us the right answer for the volume that's left over, which is really the volume around the sides here. I guess it's hard to shade it in 3 dimensions, but It's the volume that goes around and not including the 2 cones. All right, and that volume is 2,052.51 cubic inches. All right, I hope this helps, and I hope you guys find the homework easy. I'm sure you will. But let us know if you have any questions, and I hope you have a great day.